When we draw a shape in processing, we usually have to tell it where the thing is located and how big it is, and maybe some other information. Sometimes we also want to describe an angle. Either we want to rotate the object a little bit, or maybe it's like a piece of a circle and we want to describe the starting and ending angles for the shape itself. Well, in processing, there are two ways to describe angles. The first is degrees. Now, you may remember this. There are 360 degrees in a circle. If you don't remember, don't worry about it. We'll talk about this in a second. The other scheme is radians, and there are 6.28 ... numbers go on, radians in a circle. And it's just another number, it's just another numbering scheme. The reason why we have two of these is because degrees are really easy for people. Typically, if you draw a sketch on paper, you can eyeball it, and you can estimate how many degrees an angle is. If you want to be really precise, you get out a protractor, and you can actually measure the angle in degrees. But inside the computer, it's much more efficient to process in radians. So inside the machine, everything is in radians. But outside of the machine, often we want to think of things in degrees. So there are a couple of really simple little tools that let us easily move back and forth between degrees and radians. Now, there are lots of places where we have more than one way of measuring things. If you look at your thermometer, it probably has degrees centigrade and degrees Fahrenheit printed right on the thermometer. Of course, this doesn't change how warm it is outside. It just gives us two different number ranges for identifying how warm it is outside. Another place we see two scales all the time is on rulers. Your ruler probably has inches and millimeters marked on it. And again, we know it's really easy to convert from one to the other. You just multiply or divide by the right number, and you turn millimeters into inches or inches into millimeters. Another place where we see two scales is in speeds. On the left is a speed limit sign for 70 kilometers per hour. On the right, a speed limit sign for 35 miles per hour. Most car speedometers these days have both scales on them. Typically, the larger or brighter scale is the native scale in the country where the car is intended to be driven, but they're both on there because, well, both of these number scales are being used all over the place. So here we can see that the big white numbers are for miles per hour, while the small green numbers are kilometers per hour. Now, speedometers are typically arranged in this round format. It's very handy mechanically. You get that big red indicator and you just let that pivot to show you how fast you're going. But I want to work with a linear scale like we saw for the thermometer, so I'm going to straighten this out. So I'll show you how I'll do it. First, I'll put a piece of tracing paper in front of the speedometer, and then I'll put copies of the numbers on the tracing paper. Then we'll get rid of the speedometer and straighten everything out. So now I have a linear scale for miles per hour on the top and kilometers per hour on the bottom. But I just want to look at the first part of this. I just want to look at the speeds between 0 and 100 miles per hour. So I'll pull those out and set them aside. And I'll put a little scale under them so I can measure where I am. And now I have a nice little linear scale for measuring speeds between 0 and 100 miles per hour, or 0 and 160 kilometers per hour. Now I'm rounding out the kilometers per hour. It should really be 161 point something, but 160 is close enough for now. So let's measure a couple of speeds in both of these systems. Suppose we're going 50 miles an hour. How fast is that in kilometers per hour? Well, 50 is halfway between 0 and 100. So what's halfway between 0 and 160? It's 80. So that's 80 kilometers per hour. Let's do another one. Let's go halfway between 0 and 50. Well, half of 50 is 25, so we're going 25 miles per hour. Halfway between 0 and 80 is 40. So that's the same thing as 40 kilometers per hour. They both describe exactly the same speed. Okay, if you've got that, then you know everything there is to know about degrees and radians, except for the fact that the scales are different. Degrees goes from 0 to 360, And this tells us how far around the circle we've traveled. Radians goes from 0 to 6.28 There's lots and lots of more digits after that 8. For right now, keeping in mind that all those digits are there, I'm just going to pretend that there are 6.28 radians, just so I don't have to keep saying ... So let's do the very same experiment we did above. Suppose that we want to go halfway around the circle. So let's think about that in terms of degrees. If there are 360 degrees in a circle, then in half a circle, there's half of 360, and that turns out to be 180. So how many radians is that? Well, it's whatever number is halfway between 0 and 6.28. And if you get out your calculator, you'll find that's 3.14. Okay, let's do the same thing again that we did above. What's halfway between 0 and 180? Well, that'll be a quarter of the way around the circle. That's 90. And what's halfway between 0 and 3.14? Now again, get out your calculator. Turns out it's 1.57. Now, typing in numbers like 90 and 180 and 360 is very convenient, and this is why I said degrees are very nice for humans. We can type those numbers in, we can spot them, we're unlikely to make errors. But typing in numbers like 1.57 and 3.14, man, that's just error prone, particularly if you have more digits. If you type 3.14152, sooner or later, your finger's going to hit the wrong key and you wouldn't even notice it, and now you have an error in your program. So nobody wants to type all that junk. So processing gives us a shortcut. Long ago, mathematicians got sick of writing 3.1415926. It was cumbersome, plus it's not clear how many digits you want to list. That number goes on and on forever. And they said, you know what? We're just going to give that number a name. And the name is the Greek letter pi. Now, you may have seen this before. There's nothing mysterious about pi. Pi is just a number. It could have been 7 or 13, but it turns out it's 3.14159265355 blah, 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 blah. And it goes on forever. And you can look it up. But 3.14 is good enough for us for now. So when you see the Greek letter pi, just think the number 3.14. You just don't have to type 3.14. You just write pi, and that's what it means. Now, 0 radians, of course, is still 0, even if we're using pi. But what is 2 pi? All the way at the right-hand edge, 6.28. Well, that's just 2 times pi. So we write 2 pi. And you could write a little multiply symbol between those if you wanted to indicate 2 times pi. But 2 pi is pretty clear. How about what's halfway between 0 and pi? Well, remember, pi is just a number. It's nothing weird. It's the number 3.1415 whatever. So we'll just divide it by 2. Whatever that is, pi divided by 2 will work out to be 1.57 something. Now, I don't have a pi key on my keyboard, and I bet you don't either. So processing lets us type pi by just typing in pi. It's a keyword. 2 capital letters, push them together, P-I. If you type in pi as a keyword, processing says, oh, that's the number 3.1415, and it uses a very long representation with a lot of precision. So you don't have to type in 3.14159265355. You just type pi, and processing does all the rest. So let's look at the other values using this notation. 0, of course, is still 0. We have no problem with that. How about 2 pi? Well, you could actually write the number 2, and then the star, and then pi, and write out 2 times pi, and that's absolutely fine. But maybe you want to do it this way, and processing lets you. You can write 2, the number 2, underscore pi. These 6 characters taken together, TWO underscore pi, has the value 6.28 blah, 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 blah. Similarly, there's half pi, and that's just saving you the trouble of typing pi over 2. And you may prefer to type pi over 2, and that's perfectly fine. So now we have 2 ways to name any angle around a circle. In part 2, we'll see how they're arranged.